Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk. Completely off what we were just talking about is I just finished a webinar that Chris Jackson was doing. And one of the comments at the end of it is that somebody said, we miss the intro music you used to use. It's like, well, the old system I had a waiting room. You could put music behind it, something like that. Yeah. And it got so buggy and so unreliable. It wouldn't even make a whole episode without something crashing in it. And it was all kinds of reasons for it, but it was like, so I bailed on that and went to Zoom. And while there is a way we could get music in there, I just haven't figured it out yet in a convenient, practical way. But that's beside the point.
That's beside the point.
That's right.
That's okay.
But we had a good time chatting on the webinar. But we were chatting earlier, and I asked you about you mentioned that you were off for the weekend at I want to call it a pinball festival, but I think it was more of a pinball nerds convention. Or
Yes, the Pinball Nuts.
Yeah.
It was called the Texas Pinball Festival.
It was a festival. Okay.
It was a festival where all the crazy pinball nuts come, and it had been a long time since we were able to hold something this big because of the pandemic. So this was now, and there used to be one. The biggest one was in Pittsburgh called Pinburg, and it would killed by the COVID.
Mm-hmm.
So.
But you were talking about, I asked you right off, because I know you're always in there talking to the folks that design these things or own these companies.
Right.
And naturally, since you break stuff on a regular basis, you've talked about previously, even on this show, about getting it under the hood and fixing stuff and working.
Yeah, just last week or right before I came down to go to the festival, I had to pick up one of my pinball machines. I had to resolder a wire back on. After it fell off underneath. It was to a bunch of switches in series. Mm-hmm. And the nice thing is I can go to the internet and usually put it on Facebook, and all the other pinball nuts will know that problem or where the wire is. So that's part of the benefit of being in that community. But they just, pinball machines have been manufactured for 50 years or 60 years, something like that, when flippers were invented. And, not a whole lot has changed in a lot of those things.
Well, I was surprised when you described the way the flippers were assembled, as they have a smooth dowel, right?
Yeah,
a shaft,
smooth
shaft, and the flipper has a split ring on it that has a bolt.
Right.
To grip,
squeeze
right. it. And I can imagine, to be on the defense, it's a convenient way to manufacture something.
Yeah.
Alignment can be done, but it adds an adjustment during assembly and all this other stuff. The issue is that you are banging on the pinball, which is a large ball bearing as far as I'm concerned, with some mass to it, and it bangs along, and that's going to slip. It's just, we know it's going to slip because you're not bonding these two things. I imagine they're not even putting what's the tight
Loctite?
Loctite.
Yeah. No. They don't do any of that. And you basically have to visually align it on using a dot on the top of the play field for the positioning of the flipper, and then you tighten that bolt, which may slightly change the positioning. So
now I know from our previous discussions that besides not being a statistician, I didn't really gather that you had a real strong mechanical engineering background or education. You're familiar with stuff, right? But
I'm familiar with stuff, and most of my mechanical engineering knowledge has come from assembling and disassembling things like ion implanters and seeing physical switches. And the nice thing about, the benefit to mechanical engineering is a lot of times you can visually see things.
That's right. It's real hard to rewire an IC when you can't see the
you
cells.
can't see electrons, but you can see gears and wear and broken wires and mechanical,
Yeah.
switches that are broken.
Well, what fascinated me and what tipped me into like, why don't we learn from our past, or pay attention, is because you said that these things were on a smooth dowel and just a grip attachment.
Right.
And it's got a moment on it. If you're hitting it out near the end of the
Right.
tip of that flipper, you're putting a lot of torque on this thing.
Right.
And it has to be adjusted every now and then.
And it used to be in pinball machines, there used to be one pinball at a time. Now, typically, in fact, almost all pinball machines have what's called a multi-ball mode, where they may throw out up to 6 pinballs.
So you're
So you
banging
may
away
be
at
not
this
hitting,
thing.
you're banging away, but you now own not just hitting one ball at a time. You may have 3 balls on a flipper. So the mass is 3 times. And yet they're still using the design from the original, 50 years ago, the way pinball flippers were made. It's the most basic mechanical part. I mean, pop bumpers, all the other things, slingshots as we call them, they're all pretty much the same and pretty much reliable, and they don't really need a lot of change. But as an engineer, I look at it and I say, this is crazy. Why have all these years, when I have to adjust these machines, I've rebuilt flippers, that they don't have a locking gear, a spline shaft, or just a key shaft.
Yeah,
that
or a
mechanically
flat side
locks
to it.
that. Right, so that every pinball machine, and this is a difference, and maybe, it gives the player a challenge when he goes to a different pinball location and tries the same model.
It'll be slightly different angle.
It'll be slightly different angle, and that is everything on making shot, is where those flippers lay and what the angle is. And it's just, you're talking about micrometers and millimeters, that the position of where the ball is on the flipper and where it's going to go, which is the whole point of.
So we're not going to solve it for the pinball industry, but it's like you and I are not wizards of mechanical engineering, and we both look at it going, what are they thinking? Just put a key in there, Right.
And I thought about that too. And I've talked to a major manufacturer, one of the designers, and he says, oh yeah, we've thought about that. And then at the show, I was talking to a second probably largest manufacturer, and he says, oh yeah, well, and he pointed me to a booth at the show where 2 engineers, and I went up and talked to them, have actually incorporated that into the flipper assembly. In fact, they were selling replacement flippers and shafts with exactly what I was talking about, a spline, a geared shaft, so that you could lock that shaft mechanically to the plunger arm, the solenoid arm that makes that flip. And they were asking a very large expense. The problem is, for most pinball owners and operators and pinball manufacturers, is if a design works over 45 years, in general it works. It may slip a little. You may have problems tightening that. But in general, my experience is that friction grip that they use has worked for decades. And so even though if they thought of this their own or wanted to come up with it, they could have done that decades ago. But then there's 2 engineers at the show patented that.
Oh, they did?
Yeah.
Oh, good grief.
Yeah. So
no wonder the manufacturers don't want to deal with them.
Right, exactly. I said, you guys. They said, well, they're not interested, and so they're trying to sell it to the end user at $120 to replace and rebuild your whole flipper assembly, which ain't going to happen.
Yeah,
Nobody's going to go for that.
But I think the main point though is that, I mean, there's a whole ton of things that we know about mechanical engineering, and there's guidebooks and rules and all kinds of stuff out there. But I've run into this more than once, or 2 phenomena that come up to it. One is, hey, it ain't broke enough that we care enough to spend the money to do it, which is this case with the flipper attachment. But
it would cost something.
But there's also the other end of that spectrum is that and I've run into it where it's a new designer that's heads down trying to solve a problem, and they come up with a really creative new approach to, I don't know if they're motivated by getting a patent or that they don't want to read the literature or ignored everything they've learned about mechanical attachment, and they make something and they ship it, and then it doesn't work. And I'm thinking of the gull wing doors
Tesla?
on the Tesla. One of their vehicles had gull wing doors that are just a disaster. And then there's all kinds of issues here, there, and there. The automatic driving systems get the news, but they took pride in reinventing everything. And I'm like, that's usually, from a reliability point of view, a really bad idea. There's a reason that something that's been built for 50 years and works well enough is great. Fix the critical part so that it's better. But if you change everything, now you're chasing disasters one after another and recall after another to catch up the learning curve. Why can't we, and I'm including all engineers in this, is build on our history of what we know and don't know and improve it rather than throw it all away and ignore it and start over. Now, I'm grossly generalizing, but but the idea is that too many times, and you've run into it, an engineer is head down solving a problem, and it's like, well, this is really cool. And you look at it and go, well, yeah, that won't work. Or somebody else already has a patent on it, or, come on, look around a little bit. You got Google, use it.
But Fred, we do want people to innovate. We want engineers to come up with new ideas. And, the gull wing, I don't know what the big advantage is. Maybe getting into the car, it looks easier.
Cool. It's
cool. Okay.
Yeah, you can't park close to anything,
Well, okay. But, if it's just, aesthetically they wanted to change how it worked or they saw some advantages. The point is that they needed to find out before they released it. They needed to beat the crap out of it and see what it fails on that if they wanted to release it. I think they could have found, if they had, unless it's manufacturing problems, but from a design standpoint, they should have been able to establish through, vibration and, opening and closing rapidly and things like that. They could have induced that kind of
if they
thing.
had time. If they had time to do
it.
There's all kinds of reasons for that. You go back to...
They're going to pay now or they're going to pay later, whatever.
I know, and the thought was, get it on the market. We got to grab market share, and that's been very successul for them.
Yeah.
The trouble is that they're getting... Well, without discussing all their business models and everything, back to the mechanical part. And we want engineers to continue to innovate and evolve and make things better and stronger and cheaper and all those other good things. But I'm not getting on an airplane that's never been tested, or it's a brand new concept, That's why they call them test pilots, because they know they're taking a risk, right? They get paid the big bucks to risk their life essentially to make sure that craft works.
Let's give the benefit of the doubt to Tesla that they do some kind of testing. Okay.
Oh, I'm sure they do. It's just a matter of if I'm going to innovate a product, I'm thinking, let's say a laptop. Let's get out of those other markets, right? You got a brand new laptop. Right? Yeah. And you're the first one in the market with a laptop, and it's got about a 30-minute battery, and they functionally only really work. And some people will blame the operating system, but the motherboards fail, or the hard drive fails, or usually it was the power supply fails, because they were taking all these innovations and shoving it into a form factor that was nowhere near the size of the desktop that they were pulling all these parts from.
Right.
So they had to change the designs and structure and formatting of everything. And when those things first got introduced, it was, hey, you got to, at that time I called them luggables because it was a 15, 20 pound.
Well, we remember the compact portable computer, a little green screen.
It comes with a dolly so you can carry it. and then it comes with a brick for the power, which they couldn't even fit the power supply into. It was heavier than a laptop. But anyway, they were making tons of innovations just to get that form factor. Right. And it was a disaster from a business point of view of how long it lasts, but it was new and cool. And people liked the idea that they could take their computer with them, road warriors especially.
Sure.
but the market immediately demanded it got better. It would work longer. It would have better battery life. And I don't want this external power supply. But it took 20 years, 30 years for that to evolve. And so now if somebody comes out with a smartwatch, they weren't all that wonderful at the start, but it's part of this evolution of stuff is we can learn, but there's lessons learned is not a barrier to making innovation. It's a starting point, I think is my main point, is that if you're looking at a pinball machine and going to an operator or arcade and somebody's running a bunch of these machines, is, well, how much are you spending on time and energy to fix and adjust these flippers on a regular basis? And if it's less than $120, well, I'm not putting it into my manufacturing.
Exactly.
Right.
Exactly.
If it's more than that, then I'll do it. But if it's not thought through as a business plan, there's a reason for it. But if it's just, well, if it ain't broke, don't fix it. I think that's what leads us to the lack of innovation and to the lack of effort to make changes. And then the opposite end is somebody comes along and says, well, instead of a mechanical flipper, we're going to use a force field instead. You can't even see it. So it makes it a new challenge for them and completely, redesign this thing.
Well, actually, they do have that.
I know. Okay. I thought I came up with something cool.
No, they use electromagnets under the table. And one machine, I think it was the Twilight Zone, actually you turned on a magnet and it suddenly attracted the ball to essentially redirect it to act as if it was a flipper sort of. But it worked. I mean, that's an old, coil retracting. Didn't be a problem, but the problem, I guess, is comparative. You just kind of alluded to it, that if we're used to this level of maintenance for cars or whatever, and certainly one of the big advantages to electric vehicles, you get rid of the oil changes, you get rid of the
brakes last forever.
Yeah, and all
that,
right? Because you regenerate it, right? So there's just a lot of advantages there that are overcome over a gasoline-powered car. But you still, the expected maintenance, is hopefully less. But the problem with pinball machines, and the reason you'll never see them in a Dave and Buster's or any other places that, are heavily, lots of games in them, except for arcades, is because they've always historically required a lot of maintenance. They're heavily electromechanical. They've got rubber bumpers and rubber rings, O-rings that wear out and
oxidize
over time. Right, and then you've got basically sleeves in the coils, or solenoids that have a rod going back and forth for either the pop bumpers or the all of them, and
they wear out.
They wear out.
They only have so many cycles. Do they still use the big relays?
So the mechanical.
The electromechanical relays?
Oh,
is that still
these are all microprocessor powered systems.
Okay.
It's now very consolidated, and in fact, the electronics is such a small part of the machine, and I mean the boards, and it's almost like they're using an ATX board. I think one of the engineers told me that they are using basically a PC underneath the playfield to run the thing,
but sound and everything.
But it doesn't take much room. It's now very small. I mean, it's almost like you do a Raspberry Pi, and some people have made pinball machines with those little microcomputers.
Yeah.
But anyway, they are innovating all the time. They're trying to make new toys and new ways to, have a mechanism hold the ball or capture the ball or something like that. And so, we're all looking for those kind of new experiences in the machine. But, they really just, the whole world of pinball is, you take it that they're going to be required maintenance almost always over a period of time. Now, the home environment's not too bad usually, but out there in the locations, it is every week there's a pinball machine. And at this Texas Pinball Festival, by the end of the show, I would say about 30% of those machines, out of 100 or maybe 300 machines, about 30% were failed.
Wow.
Yeah.
And at some point, that's just going to become, somebody's going to come out with one that just lasts 10 years without any maintenance whatsoever, and kind of blow everybody else away. But
I mean, you could, they do have the big pinball simulators that have a big LCD panel in a box.
Yeah, I saw that. That's just so fake that it's like you've seen a little picture of a pinball coming down at you, and
that's why we, even though your PlayStation and your Xbox all have programs to simulate a pinball table, it's not the same as a physical pinball system. And the steel ball bouncing around, the randomness of it, how it can be an air ball where it flies over a rail because it hits something. Those are all not, that's what's missing. And so we're all still enjoying the real pinball machine more than, what you can put on your iPad or your phone, which is okay for learning the rules of certain games and stuff like that. But
we'll wrap it up here. But the favorite application I've seen for an iPad is it turns the screen into like a fish tank that you're looking down on. So there's fish are swimming through the screen and stuff. And of course there's a cat video of that. The cat's playing with it. Yeah. And as the cat touches the screen, the fish respond to it and move away. Stuff like that.
So you hold it up to your cat and he can have fun with it.
That's right.
Your cats try it?
Oh, no. They were not interested at all. Typical cats, I thought I'd make them famous. But there's only so much you can do.
A laser pointer will really do great for them.
They were going to they're like, whatever. No, but the idea is that you can simulate stuff, but there's also a tactical or tactile sensory difference from a mechanical system versus not mechanical.
Yes.
And I can do my whole dashboard of my car in one big LCD screen.
Right.
Except the law says you have to have a mechanical odometer or something like that. I think that's changed because I don't think my odometer is mechanical.
No, I don't think any of them are mechanical now
anymore. But
that is a protected chip, though. They make sure that you can't turn it.
But the idea is that we've evolved for thousands of years of mechanical innovations and building all these information, and it's behooves us as an engineer to pay attention to the lessons learned, because they're usually things that will save you a ton of time and energy and stuff. Innovation's great, but innovation for the sake of innovating alone, I don't think is useful. And it's got to have a business model. It's got to be a customer acceptance, all those other factors to it. But there's, not taking advantage of what we already know to reduce the maintenance load. And there may be other parts of the machine that would benefit way more from, learning what we've learned before.
Right.
But it applies to any industry, is pay attention to the history and the trajectory of those histories. And there's cases where you need to disrupt that. That makes sense. But that should be deliberate as a disruption and well thought out, because you almost always start at the bottom of the heap from a reliability point of view doing that. There are exceptions, I'm sure. So if you're listening to this and you know of a great exception where the innovation just really revolutionized a part of the mechanical world, let us know. Or if you're on our team here, or at least my team, saying, hey, no, there's stuff that we need to pay attention to. Love to hear from you on that. And if you like pinball, give Kirk a shout. He'll tell you about a great festival.
We could talk about it endlessly, but I'm all for innovation. But I think when you innovate, you really need to take a super, super big emphasis on testing for reliability and actually physically the first samples and everything you do, you plan, especially, and that's what we do in companies we look at, I worked for in the past, is any major change or any new technology, that would be the focus. That's where we go
sort it out. How's it going to fail? When will it fail?
Roll wings doors have been around for a long time. Tesla must have had some history of knowing what the problems are, but then they needed to find out themselves. And maybe they didn't have time, but, we talk about pay now, pay later. And you pay now and you save a lot of money. So Anyway,
all sounds good, Kirk. And I'll ask you about the next festival as we get around to it. But in the meantime, keep your systems running.
I will be playing pinball today.
All right. So if you got a question for us or a comment, let us know. Head over to accendoreliability.com/go/SOR. A couple of ways for you to get in touch with us there. No pinball skills necessary. and you can go, Kirk and I and the other hosts of the show are available through LinkedIn and through email. And so there's lots of ways you can get in touch with us. And in fact, Kirk, I want to talk to you about a question I got the other day.
Okay.
So we'll bring that up on the next episode. So we'll talk to you again real soon.
All right, Fred. Good to talk to you.
Yeah, cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.